going to demonstrate a problem for you today using calculus. Now I know that there are easier ways to do this problem than the way that I'm going to use, but remember my basic objective here is to get you to understand the relationship between derivatives and integrals. Remember that the opposite of integration is differentiation and vice versa. So we're going to start with a function, take the differentiation of that function, and arrive with a rate of change. Taking that integral of that function will take us literally right back to where we started, and then we'll plug values into that function. Now for this particular problem, were we really to do it, we would actually just plug into that original function. But again, that's not the point, and that's not what I want you to see. As you're watching this demonstration, I want you to concentrate on the relationship between differentiation and integration. Alright, here's our function. Hopefully this is familiar to all of you. It's the function to figure the total amount of money that is in a bank account at any point in time. Remember that our balance that is in that account equals the initial balance that you have times e to the 0.06t in this case. Because what I'm going to do is presume that my initial balance is $1,000 and that it's a continuous interest rate of 6%. Now, it's important to remember that balance gives you the total amount that is in the account at that time. Literally, the amount that you had to begin with, your initial balance, plus any interest that's been earned. In this case, remember that balance is in American dollars and that our variable t is in years. So if we take the first derivative of this, remember the first derivative gives us our slope of the tangent line, or the rate of change that's occurring in dollars per year. And the reason that's true is, remember, your first derivative again is the slope of the tangent line, which is like the change in y over the change in x, or the change in your dependent variable over the change in your independent variable. In this case, that would literally be dollars per year. So taking the first derivative of this function will give us the rate of change in that bank account in dollars per year. Okay, let's actually do that integration now. Here's our initial equation again. To take the first derivative, basically what I'd like to do is move that 1,000 off to the side for a second and just take the derivative of e to the 0.06t, which gives us this. Multiplying by the 1,000 again gives us our final answer for the first derivative of b of 60e to the 0.06t. Now, what I'd like you to do is pretend that you are now seeing this problem for the first time. I'm going to give you a new problem wherein the problem reads like this. The rate of change on your bank account can be given by this formula. Now, of course, we just derived that formula, but on a normal integration problem, you wouldn't be given any of that initial information. You would just be given some sort of a rate of change. In this case, the rate of change in dollars per year is equal to 60e to the 0.06t, and I want you to find the total interest rate that will be earned on that account for the first 3 years. To do that, we'll need to take the integral of this function from 0 to 3. Now, mechanically, what do? Of course, is we take that 60 and we move it off to the side for a second and just take the integral of the e to the 0.06t part. Taking the integral gives me this, which will need to be evaluated from 0 to 3. Before I do that, though, I will go ahead and take my 60 divided by the 0.06, which gives me this function. Now, hopefully, you recognize that this is literally the very first equation that we started off with at the very beginning. But of course, you didn't know that. We're just doing a simple integration problem. Now, let's go ahead and evaluate this integral from 0 to 3. When we do that, we literally get 1,000 times e to the 0.06 times 3 minus the 1,000 times e to the 0.06 times 0. This first value, if you put it in your calculator, you get 1,197.22. The second one, since e to the 0 is literally 1, gives us our initial balance. And of course, the difference between these two, the difference between what it is after 3 years and 0 years is the actual interest. Remember, the integral always gives you how much it changed between those 2 points. Notice, by the way, that this is exactly the same thing that I would have gotten had I plugged 3 and 0 into my initial function. So literally, I could have taken b to the third minus b of 3 minus b of 0, which would have given me the total amount that's in the account after 3 years minus the total amount that's in the account after 0 years, which of course was just my initial amount. And the difference between these two gives me the growth in that account between those 2 years.